Hi, I'm Harvey Sachs, and thank you for joining this webcast of Hot Water Forum 2022, Session 6A, Residential Heat Pump Water Heaters, 120 volt. Again, I'm Harvey Sachs at ACEEE, and I wear the title of a visiting fellow, an honorific conferred to those who have retired from ACEEE without leaving. We'll start the webcast with a few housekeeping notes. First, please join me in thanking all of you and to thank all our sponsors and ACEEE ally members for their support of the Hot Water Forum and ACEEE. Please use the chat box on the right side of your screen to ask questions of the presenters. They will not be able to respond to your questions in the chat. As moderator, I'll do my best to gather all the questions and share for the presenters to answer once the presentations are complete. If we don't get to your question, please join us for 20 minutes of chat and discussion on the Zoom platform immediately following this session. The Zoom link will be posted on the audience screen at the very bottom. Please refrain from using the chat for any dialogue other than asking questions. Please be sure to check out all the tabs on the left-hand side of the app. From there, you can network with attendees and program participants, visit sponsor pages, and engage in our game to possibly win a free registration to the 2023 Hot Water Forum in Mission Hills, California. The resources section includes the program and a list of attendees for downloading. Last, we ask everyone to please help in planning our future hot water forums by completing the conference evaluation. If you complete the evaluation and include a testimonial, you'll receive a $25 discount off your registration for the 2023 Hot Water Forum. All presentations will be available for on-demand viewing to registered attendees on the Socio platform within a few days, and they will remain available for viewing until May. The presenters' slides can be found on their page in the Program Participants section. Now I'd like to introduce our distinguished panel of speakers. Amruta Kanolkar is a Senior Project Manager at the New Buildings Institute. Peter Florin is a Senior Product Manager with Energy Solutions, and Micah Sweeney is a Senior Research Engineer at the Electric Power Research Institution. We'll start with our first speaker, Amruta, and here's a brief bio. She's at the New Buildings Institute. Her expertise includes emerging technologies, measure development, building energy and life cycle analysis, and zero energy design. Formerly, she worked at PAE and Smith Group JJR as a mechanical engineer. Amruta has a Master of Science degree in Energy Efficient and Climate Responsive Built Environment from Arizona State University. With that, please join me in welcoming Amruta.
Hello all. Amruta Kanolkar. Thank you, Harvey, for the warm welcome. I'm Amruta. As Harvey mentioned, I work at New Buildings Institute, and I'm going to share my screen now. Kate, can you confirm you can see my screen? All right, I'm going to assume that you can see my screen. And with that, so today I'll give you an overview of retrofit-ready, game-changing water heating technology, the 120 volt heat pump water heaters. So I will start with giving you so I'll go over the national market opportunity, give a brief introduction of where the technologies are and the product overview, then diving deeper into the technology validation effort that is happening on the West Coast. And then finally, market commercialization plans, market readiness efforts that are happening. So just for some context, there are about 118 million existing water heaters nationally, and um, and about 4.6 million commercial water heaters. Out of those 118 million water heaters, 40 million water heaters are 10 years and older. So some background, like typically water heater life is about 12 to 13 years. So close to 50% of the national water heating stock is older and about and ready for replacement. 7 million water heaters get replaced every year. So there is great opportunity for for an emerging technology which can be a retrofit ready technology, which can be where you do not need much of a panel upgrade or wiring upgrade, and I will go over the details soon. But this shows the market opportunity with this emerging technology. So on this slide, the slide shows the water heating stock, the national water heating stock. The last row shows that about 50% of nation's water heating stock, and like about 90% of California's water heating stock is directly pumping fossil fuel for heating water. So everything from dark green, dark blue, and the all the other colors on the right hand side are all fossil fuel, like either gas, propane, or oil fueled water heaters. Just in California, only 7% of California's water heating stock is electric, and that to electric resistance. Nationally, currently, the water heating stock, I'm sure everybody knows, is just 2.2%. Heat pump water heater, heat pump water heaters are just 2.2%. So for like 50% of the people nationally, or let's say 90%, more than 90% of people in California, if they want to heat their water, the only option they have currently is going for expensive and extensive panel upgrades. um, because like if you have an existing gas water heater, then you do not have a 240 volt higher amperage um, plug next to the water heater. Typically you have the 120 volt lower amperage plug available. So this technology, the 120 volt heat pump water heaters which are hitting the market right now, if validated, will no longer require the 240 voltage um, plug point next to the water heater, and the customers can use the existing plug point which is available and install these 120 volt heat pump water heaters. So with that national, so basically just wanted to emphasize that this technology, if validated, has tremendous opportunity to decarbonize the water heating sector. With that, I next few slides I will go over the technology and the product overview. For those of you who have already attended the manufacturer perspective presentation that was moderated by Jim Lutz, you must have heard from the manufacturers in depth about the products. But I do plan to briefly touch over, what's coming. So about just some background about couple of in 2018, group of stakeholders identified a gap for retrofit ready water heater which can be plugged into an existing available plug without any panel or wiring upgrades, and which is also which is specifically designed for space and power constraint applications. And a specification was written, and within 2 to 3 years there are about 4 to 5 manufacturers which are hitting the market this like between last year and this year. So there are a couple of them are already available, and some more are coming to market in 2022. So these are going to be shared or dedicated circuit plug-in heat pump water heaters. most of them are going to have an integrated electronic mixing valve. They're going to be available in different tank sizes. All of them are going to be CTA 2045 capable, load shifting capable. Um, and they are also going to have a built-in Wi-Fi module to connect to a cloud services. Um, so how are the manufacturers, taking care of, like, using the lower input and still going to heat the water and satisfy the customers? The most of the manufacturers, the way they are doing that is with the help of an integrated electronic mixing valve. So they are typically, you heat, like water heaters heat the water, the incoming water is at like 120 degree or 125-degree Fahrenheit. But in this technology, the water will be heated at 140 or 160-degree Fahrenheit and stored in the storage tank. And with the help of electronic mixing valve, then it will be used at a later time. So that's how, even though it does not have a higher input, they will be able to, they will be able to satisfy the customer needs. This shows the four manufacturers that are about market ready. The Reams, Proterra. So again, Ream has a dedicated circuit and a shared circuit model. The shared circuit model is 15 amperage, a breaker size. All of these are all of the shared circuit models are 15 amperage breaker size, but actual current pull is about 10 to 8 to 10 amps. So really low current. Nile is 80 gallon. This again, theirs is going to be a split system with a compressor and a storage tank. And then G is in 50, 65, 80 gallons. Niles is in 50 and 80 gallon. And Ream is in different sizes available as well. As I said, like, since the manufacturers have covered in the manufacturer perspective most of the in-depth details, I was planning to highlight more of about the technology. Like, this slide compares the 120 volt heat pump water heaters to the 240 volt and shows, what application is ideal. For example, for 120 volt are specifically targeted for the retrofit market for gas and propane replacements, whereas the 240 volt is for new construction as well as retrofits. The electrical 120 volts should not require in electrical panel upgrades. The first hour rating is lower, and I will go over the details of, the first hour rating and inputs in the next slide. The electrical requirements, as I mentioned, for the 120 volt, majority of the models are going to be shared 120 volt 15 amp models, whereas for the 240 volt, it's the dedicated, requires a dedicated 30 to 40 amp circuit. These are the 120 volt water heaters are going to be available in a space constrained applications. As I mentioned, since they are targeting the retrofit market, vintages and space constraint and power constraint are some of the key criterias around which the specifications were developed. That's why manufacturers are making sure that this targeted well served. Some of the models does have a supplemental heat, but with a lower input, and all of the models are going to be grid capable, connected. So in this slide, I have compared like the different fuel types just to show you the input heating capacity compared to a first hour rating or the tank heating time. So the first column is the natural gas water heater. The second one is electric resistance, and then heat pump water heater 240 volt and 120 volt. So if you see the second row, the heating capacity of a 120 volt heat pump water heater is almost 3 to 7 times lower than an electric resistance and a natural gas water heater. And that absolutely impacts the tank heating time. They do have a higher tank heating time compared to other technologies, and so the first hour rating. But the whole point is having this lower input plug and ready heat pump water heater available, which can absolutely support the retrofit market. So with that, the next few slides, I will cover the field study effort that is happening on the west side, on the west coast. So we are working, a New Buildings Institute is working on a technology field validation effort in California. And the research goal for the field study is independently validating the 120 volt heat pump water heaters for their performance, making sure that they can absolutely perform and provide that hot water at lower input, and also understanding the customer satisfaction and installer acceptance. The secondary objective of the field study is supporting this technology with market commercialization and readiness. So, for the field study, we are using three key research methodologies. Under the monitoring and measurement, we are making sure that the hot water runout events are captured, the energy performance will be validated, and we are also on key sites, we will be also validating the load shifting capabilities of the heat pump water or of the 120 volt heat pump water heaters. We are also going to pre and post analyze the green button data and also the simulated performance, um, with the help of of a meter data, also to performing meter data, and this will help with uh, understanding the pre-install energy and operating cost, and also the post-install analysis. um, and we'll be documenting the product and installation cost. And finally, we are also surveying the customers pre on throughout the field study, and also the installers for the installer experience. We are targeting 5 key site selection criterias. So throughout California, as I mentioned, this field study is targeted in California. We are looking at about 32 sites in California and trying to target all the climate zones from Northern California to Southern California. Single family and multifamily building types, low and medium hot water demand, um, and install location. So for install location, we are trying to we have sites. Actually, we have sites selected now. We have indoor installs, outdoor installs, conditioned installs, non-conditioned installs, in closet installs, particularly multifamily in closet installs, to make sure that the space constraint criteria is also met. And finally, the vintages of home, to show us, to validate the electrical panel, the power constraint application. So 12 sites in PG&E territory, 8 sites in SCE territory, and 12 sites in SMART territory. As I mentioned, the secondary objective of the field study is also to make a support with market readiness of the technology and building demand. So, the field study should also help with developing regulatory measure papers, like, measure development, incentive program recommendations, like developing programs around this technology, raising awareness, developing case studies and trainings. Where are we with the field study? So, um, we have funding from Southern California Edison, SMUD, PG&E, and Tech, the statewide Clean California program, thanks to our funders. Looking at about 32 sites in California, we have a technical advisory committee who is advising us on on the field study. site selection criteria, like selected, site selected, survey implementation happening, a monitoring plan and instrumentation plan developed. Currently, we are recruiting the participants and also developing a load shifting capability test plan. This shows where this shows the statewide uh, reach with the field study. That also shows the climate zones that we are targeting, like from colder climate to milder and hotter climate throughout California. The size of the bubbles mean the demand that we are within these sites. We are also trying to get to different different demands, like from low, medium, and high demands. And again, the graph on the right shows the targeted sites and the current sites that we have available that are mapping against the site criteria that I mentioned. Finally, I wanted to just mention that the field study is part of the Advanced Water Heating Initiative effort. So the Advanced Water Heating Initiative is a market transformation effort to help increase the adoption and demand of heat pump water heaters nationally. There are about 150 organizations involved in this effort to help accelerate the market adoption of heat pump water heaters. And the graph below shows there are manufacturers, utilities, industry associates um, participating in this initiative. If you are interested and want to read more about the field study, I have the link for the field study is available at the end of the slides. And with that, I just wanted to thank you and mention that my email address is here. If you have any questions, please do reach out. I also wanted to mention that in addition to California, we are now also expanding the field effort nationally. So if you are interested or in another region and want to test this technology, please reach out and I'll be happy to support. Thank you.
Thank you, Amruta. Our next speaker is Peter Florin, Senior Project Manager with Energy Solutions. He oversees the implementation of the Tech Clean California initiative and the Bayran Heat Pump Water Heater Contractor Incentive Program. His role includes incentive design and implementation, contractor outreach, consumer education, and utility program integration. So let's let him have it. Peter, you're on.
Thank you for that introduction, Harvey, and good morning or good afternoon, everybody. So for this morning, I will just be giving, fairly brief presentation about, the utility and installer perspective about this retrofit-ready, game-changing technology. This be talking specifically around some of the efforts being conducted by tech to ensure this product is ready for prime time. So while there have been field studies and localized tests for the 120 volts, Amruta just spoke to really a key one. Utilities and installers are looking to get some key questions answered before some of them would really be comfortable going all in. For the utility side, especially investor-owned utilities, their program designs are most often driven by what can be cost effective. And also, if they stand up a program, will they get participation? So some of those key questions they need answered is there a market? What is the equipment cost? What is the cost over a baseline equipment? What are the energy savings? And ultimately, is the measure cost effective? Contractors, on the other hand, have said to me time and time again that they are very, very busy already in California. And so for them to pick up a new arm of business, they really need to have some reassurance that they will have customers who will want to install it, that they know how to install it, that they'll have happy customers, and maybe how they need to price the product in comparison to other products that they are already putting in. So again, just heard from Amrita about some of the efforts being done to get the 120-volt product ready for prime time. And so I'm going to go a little bit more into what tech is doing to help follow it up and drive towards increased scale for all the utility program and installer readiness indicators. So one of the first questions is there a market for it? This question can be easily answered, or what is tech doing to help build the market and answer the question? So tech is already coming in with significant incentives, and right now, a lot of them have been focused just on supporting the standard 240-volt models going in. We are incentivizing the 120-volt products, and they are eligible for the same incentives as the 240-volt. We're limiting incentives based on the project cost. So if there's less of a project cost, we won't be overpaying. But having the same incentives available really ensures that customers don't necessarily have to make a decision on product types solely based off of what pays the highest incentive. And for a product that likely has significantly lower install cost, these incentives will more than likely cover the complete cost. So with these incentives, we truly expect that there will start to be a market being built for these products. So having a market but not having a set of knowledgeable installers, that would be a disconnect. And so tech is also making significant efforts to grow the number of knowledgeable installers. So to date, we have enrolled over 600 contractors statewide, and it is growing. And this is really important, not just because these contractors are eligible to receive incentives, but that means that we have 600 plus installers who we can engage with one-on-one and in group settings to learn valuable installation experience. We have also been making specific efforts to enroll contractors who are partnered with retailers, which will be a key avenue for 120-volt sales. So the specifics are, can we get contractors set up in this program to take advantage of the incentives and take advantage of the sales where they are being made? And again, one of the key questions is getting some of the new product types out to installers well ahead of time. And so again, with 600 plus statewide, this gives us a direct avenue to do so. So building on that, building a set of knowledgeable installers further, one of the most exciting things that tech will be doing, and we are coming to our final stages of setting this up, is our heat pump water heater bulk purchase or giveaway program. It's a lot easier to sell what you know. Contractors have said that directly, as they are really comfortable selling what they know. And so this effort gives us an opportunity to get contractors familiar with the technology without them having to necessarily sell it and go to customers before they're ready for it. So this heat pump water heater bulk purchase and giveaway, characteristics of it is it provides eligible contractors with a free heat pump water heater to install in their own home to help them gain valuable real life experience of living with and operating a new technology. So not only will they get experience installing it, but they can get experience living with it. So now they can talk to customers and tell them, exactly what is the experience. If there's some changes that they should expect, they will be able to speak from it firsthand. And we've heard from customers that if a contractor is able to tell them from their own real life experience, that goes a long way in helping them feel comfortable. So specifically for this, we have a carve out for 120-volt heat pump water heaters. And this is really the fastest way to get a new product into the hands of the installers. And once the installers receive these water heaters, that's not going to be it. We're not going to step away. We will be talking with them over time to hear not only what their installation experience was like, but maybe any key operations feedback that we can incorporate into trainings and marketing materials in the future. So again, this is probably one of the most exciting aspects coming out of tech, and we do expect this to be launching in the very near term. So continuing about training, manufacturers really know how to train their products best. And one other aspect of tech we're doing is aligning manufacturers' training efforts with other utility or other industry stakeholder training efforts. So we've been in discussion with manufacturers to figure out how to make that pairing go well. And so if we are able to align all industry stakeholders towards the goal of heat pump adoption, that provides specific opportunities to integrate 120-volt training into those existing training courses. Again, manufacturers know their products best, and so it is best to have them get integrated directly into those training efforts. So switching gears some, mentioned that utilities are really looking for what measures can be cost effective. If they're going to start a program, especially investor-owned utilities, they need to have answers around what the energy and cost data is for the product. So to this end, tech will be collecting installation data gathered from claim applications, and this will all be published on a public-facing dashboard. So we expect by the time tech concludes, it will be the largest centralized source of heat pump water heater data, and especially 120-volt installation cost data. So this not only will help answer some of the utilities' questions around what is the cost to install so they can build it into their cost effectiveness calculations, but it also could help reduce the risk to consumers and installers who are considering 120-volt products. It helps illuminate maybe what are some costs that they should expect. So on the other side of the coin, there is what is the energy savings from the technology? And again, this is another question that utilities need to get answered. So for any installation that receives tech incentives, the customer's gas and electric consumption data will be run through the Recurve platform, and it will be able to pick out what is the actual greenhouse gas reductions for the product, or maybe what is the actual energy savings. And again, we'd expect this to be the largest set of heat pump related electricity and gas consumption data analysis, cost consumption cost analysis. So these two sets of data combined, we truly believe will be enough for utilities to make some of the hard decisions around what products to incentivize in the future. So again, that was brief. Just wanted to lay the groundwork about, how utilities are looking at this product today, what we've been hearing from contractors. We're excited to keep everybody in the loop around progress to this. And so if you'd like to know more around what tech is doing specifically for the 120-volt product or just heat pumps in general, please reach out, and contact information is listed on the screen. Thank you very much.
Thank you, Peter. Our next speaker, our last speaker, is Micah Sweeney, Senior Research Engineer at the Electric Power Research Institute, where he's a member of the Research Program 170 on Customer Technologies. His primary expertise includes the evaluation of emerging technologies for energy efficiency, demand response, and electrification in data centers, HVAC, and water heating through assessment of these technologies in the laboratory and field settings. Micah is an ASHRAE member and completed the BS in Electrical Engineering from the University of Illinois at Urbana-Champaign, and his MS in Electrical Engineering from the University of Tennessee in Knoxville. So take it away, and thank you very much, Micah, for joining us.
Thanks, Harvey. Hi, everyone. I'm Micah Sweeney. I'm pleased to share with you some results from our testing here at EPRI around a heat pump water heater product that may address at least one of these, perhaps two of these barriers we've reviewed today. Very briefly, I want to touch on who is EPRI, just as a reminder. We're the Electric Power Research Institute, a nonprofit, independent, collaborative research group that conducts scientific and technological research on behalf of the electric power industry. And my group in Customer Technologies evaluates these end-use devices, the emerging technologies that may find their way into utility programs in one way or another. And we've been pretty active in water heating research over the years. And as our sessions really focused on this 120 volt segment that addresses, I referred to it as a couple different market barriers here, not just around the electrical infrastructure, but also the form factor limitations. And so in this project, we sought to more so focus on perhaps the form factor in by evaluating two models from a European manufacturer, models available in Europe that can address this market barrier, this segment that may not be currently met in the U.S. Again, working with our sponsor, Southern California Edison, and appreciate their support. Recognizing there are certain applications that are poorly suited to typical heat pump water heaters on the U.S. market, and so we've talked about the electrical, but also the form factor, which may include multifamily and manufactured housing, and certain commercial applications, restrooms, perhaps small restrooms or break rooms, any place you might find a low boy water heater. And so in this project, we found two European models, tested them in our laboratory under standard US metrics to get a sense of how that would translate to the North American market. And so in terms of UEF, the efficiency metrics, and FHR, the capacity, and then possibly identify some modifications or enhancements for adaptation to the US. So both of the products we tested were from this Ariston product line. We tested two different sizes here. It's an Italian company. This is a wall-mounted unit, and so that's a more typical application in Europe, less so in the US. As you can see, or as I've kind of depicted in arrows here, the water and electrical connections are from the bottom, and that is a little bit obviously different than US, and there's a little different requirements in that way. But it's an integrated unit with a coil, condenser coil around the tank, and the resistive element through the bottom. And we're showing kind of the optional inlet and outlet ducting connections through the top there as well. We tested a 21 and 29 gallon units, and I kind of pointed out the power requirements here, the 1200 watt backup heating element, and the 350 watt compressor. This would pretty easily fit into the standard 120 volt 15 amp circuit in the US that we're in this session trying to address the electrical infrastructure requirements. But of course, these are designed for European requirements and would require some changes in that regard. So to put this form factor, the sizing into context here, we showed them against some of the other most common water heaters in this category. And we've heard from our understanding of the market and discussions with manufacturers that the 40 gallon models are among the most popular with consumers in the US. So I have these here as reference, including the 40 gallon, the smallest heat pump water heater, 240 volt water heater on the market today, and comparing it with a 28 gallon low boy. You see we're kind of in the middle there, in the same range. And I guess I'll point out again before moving on, because these are wall mounted and would have some connections to the bottom, they would require clearance on the bottom. Again, a little different installation considerations. But these units had five operating modes, and we focused on the three, we'd call them primary operating modes here. An auto mode that's similar to a hybrid that uses the heat pump and stages the elements as needed. Its green mode is kind of the heat pump only or high efficiency mode that comes as default right out of the box. And the boost mode is analogous to a high demand mode, very similar to auto mode. And we really found very little difference between auto and boost in our testing. But I'll point out here that because these units ship with green as the default mode, per the DOE specification for standard performance metrics, testing would be done in default or green mode in this case, which is, again, a little different than typical North American units, but we tested in all three. So I'll start out with the FHR test, the first hour rating that gives a idea of the capacity, hot water delivered capacity here. We're showing this is unit power in orange, the hot water delivered in blue as a cumulative over time, and the outlet temperature in red at the bottom. And I'll just kind of very quickly recap, if you haven't done FHR testing in a while, that the test spec calls for you to draw water until the outlet temperature has fallen 15 degrees from its maximum observed temperature during that draw. And so by 15-degree draw, you see we got one about 15-gallon draw, and then allowed the unit to recharge over the hour. And at 60 minutes, it's de-energized, and a final draw is allowed. And any water above that prior cutoff temperature is included in its FHR and added to its hot water capacity. And so I go through that kind of nuance and detail here of the FHR testing, where with the smaller unit, we got 2 draws for 30 gallons. I go through that nuance because our larger unit, we found, did not reheat fast enough for that final draw to be included. So the first question would be, well, why does the larger unit have a lower FHR rating? Well, in our testing, we found it did not reheat fast enough, so that final draw was not included into its rating. And so that's the answer why. Kind of an interesting finding here. But on the whole, as we expected, in green mode and heat pump mode, was not able to reheat fast enough for a second draw to be included either. So the heat pump mode, the green mode, capacity was about half of the auto mode for that smaller unit. And then the larger unit only had 1 draw in all 3 of the modes, and so had 21 to 23 gallons of capacity. So clearly a bit lower than typical units the other heat pump water heaters we're evaluating. And I'll kind of point out one of the things we found in our testing. Because that resistive element was in the bottom of the tank, when it came on, it tended to heat up and mix the whole tank. It limited the stratification of the tank because the element was placed at the bottom. Most of the units in North America have the two elements, top and bottom, and would heat in sequence and maintain some stratification. That helps keep outlet temperatures high and also has some implications for recharging efficiency. It was kind of an interesting finding from our testing. Again, we followed the DOE procedure with the 6 thermocouples equally spaced within the tank. And so I didn't show all of that data here for simplicity, but that arose from our data collection. And for comparison here, the Energy Star specifications require 45 gallons for first hour rating. So today, there obviously is not a category in which these would qualify. Okay, a reminder on the Uef testing procedure. It's a uniform energy factor meant to test the charging efficiency or the efficiency of a water heater, and is done under a simulated demand profile. And in this case, because FHR fell below 50 gallons for these models, they fell into the low usage draw profile, and I've shown it here. This is the draw profile that we used specifically. A little bit condensed standby period so we could observe it during business hours. But it's a total of 38 gallons, dominated by 3 primary water draws at the very beginning, in the middle, and at the end of the testing. Again, pretty precisely controlled to 1 gallon and 1.7 gallons per minute. And I want to point out again here, many of these 40-gallon units that we've been talking about would fall into a higher load profile, a medium usage draw profile, because their FHRs are typically over 50. So just another kind of aside here. Looking at our results from Uef testing, here's the smaller unit, the 21-gallon unit on the left here, is showing the very similar plots with power in orange, water volume in blue, and outlet temperature in red here. And you'll see kind of first thing is that over the course of this simulated day, that in auto mode, these units tended to rely more so on the elements, the resistive element, singular, one element per unit, and then the heat pump, more so than we expected. You'll see there during that first draw, or really it's the second draw, at about 17 gallons, that the outlet temperature dropped under 100 degrees. That aligns with our FHR testing. We couldn't get 17 gallons in one draw, but throughout the rest of the test, it held temperature pretty steady. And the other thing I'll point out, interesting that it did not immediately begin recharging after that first midday draw at about noon. That's 7 gallons there. So some question as to what the exact temperature triggers are for recharging. That wasn't evident or self-evident from our tests. But this smaller unit then at auto mode, well, we measured at 1.4 UEF. Larger unit, a little different. It didn't recharge during the middle of the day, a little surprisingly, and thus, and when it did recharge at the end of the day, relied more heavily on the heat pump, so its UEF was a little higher, and its outlet temperature held fairly constant through the tests. So between these two, again, found the UEF to be about 20% higher for the larger unit. That's roughly in line with the trends we found for other products in the North American market. And we found that green mode roughly doubled the efficiency over auto mode. I didn't show those plots here, but yeah, took quite a bit longer to reheat. And again, for comparison here, we've got the Energy Star criteria for 120 volt products is the latest standards. Latest specifications call for a UEF above 2.2. So these units would qualify in green mode. So overall, these models that we tested appear well suited to applications with smaller water draw needs, smaller hot water demand around 20-30 gallons, such as could be a small residential or point of use application. We found a few potential optimizations for the US performance metrics, a few ways where these may have differed somewhat from other American models. I think the first of which, with the resistive element at the top, could be an enhancement to, again, enhance stratification, increase the hot water outlet temperature, and allow a little more first hour delivery. Of course, increasing the element wattage would also increase the first hour capacity, especially on the larger unit, perhaps allowing it to include both of its water draws in its rated value. Of course, the trade-off there may be whether you fall into the 120 volt, 15 amp circuit requirements, the electrical infrastructure requirements. And finally, some modification of a compressor and element staging or coordination could help it improve its UEF during the standard US simulated demand profiles. Clearly, it wasn't quite optimized for that usage pattern as we would expect for a typical model in North America. Got my contact info here for any questions or follow-up, but we're happy to answer some of these during the Zoom.
We'll now we would have addressed a few questions from the audience, but I don't see any. Do you, Kate? Kate's our producer. Kate, we're not hearing you. Do you see any questions?
Hi, Harvey. There are questions to the left of your screen in the chat. Hopefully we can fill up the last 10 minutes with some questions before heading to Zoom. And I will put all the rest of the speakers back on screen so we can answer a couple questions real quick before we migrate.
I'm only laughing because I'm seeing them on the right side and I was not seeing them. Our first question is from Bob Hitchner. Amruta, listening to your presentation and that of the manufacturers yesterday, seems the most critical challenge is to make sure that homeowners are happy with their heat pump water heaters. Manufacturers kept saying if the water heater is sized properly, the homeowner will be happy. How do we educate the market so we always put in a large enough 120 volt heat pump water heater? If we get it wrong at the beginning, we could kill the category by giving it a bad rep and scaring plumbers away.
Mhm. Absolutely, Bob. That's a key question. Even we are trying to make sure that the technology doesn't fall flat on the face. So it is really important for the market, specifically for the installers, to understand the sizing. So right now, through the field study, we are making sure that we are documenting all the sizing criterias, or we are working closely with the manufacturers to understand, the mapping the right households to the right products, the tank sizes, and also documenting the findings from the installations to create like a best practices or key to document all these what is it criteria so that we can train the market accordingly. So at least right now the hope is the field study and findings from the field study with that we should be able to train the market on the right practices. But I totally agree with what with the concern that the market awareness and training the installers is going to be key for the technology success.
David Garza asked if it would be possible to get these slides as in the other presentations. And I believe that question goes to Kate, and I believe the answer is yes.
Yes, the slides will be available after the presentation.
And Heather McDermott asked a question that I can't see because it's underneath my screen and I don't see a scrolling mechanism. Okay.
Heather is asking if there is any work being done in Canada to promote 120 volt heat pump water heaters. And Heather, I am not aware of any work, particularly towards 120 volt heat pump water heaters. To test but I do want to mention that we are currently working in the Midwest to test these 120 volt, particularly for colder climates. Again, it's not going to be exactly similar to Canada's cold, but yes, we are trying to test this technology in colder climate in Midwest.
Evan McCune asked when the estimated completion of the field study is going to be. Are the manufacturers waiting for the completion before putting their products on the market, or are they out now?
Yeah, so we are looking at about Q1 of 2023. So the field study is going to be we are trying to capture all the 12 months, and winter and summer months are going to be key for the field study findings. So looking at like Q1 of 2023 for the completion. And about your question whether the manufacturers are waiting for the field study findings to come to market, yes. So I would say not all. 3 manufacturers or in fact 2 manufacturers out of 4 are going to be ready market ready before, like, now. Nile is already ready. The products are purchasable. Ream will be ready now, and then there are going to be manufacturers who are going to wait for the field study findings before they are going to be production ready.
Thank you. David Winiarski asks, do you have a source of data for the distribution of electric panel sizes throughout California homes? And if so, characteristics of homes using smaller or larger panel sizes?
And then I can take some of that, and Micah or Peter, feel free to add. So right now, just based on the 32, so for the 32 sites field study, we have received more than 100 participant interests, and we have been screening them. So walkthrough surveys, and we're trying to capture all the characteristics from the participants. So for those we have with whom we have done the walkthrough surveys, we have been capturing the panel sizes and trying to map that against the home characteristics. But again, that's like limited to the field study and those 100 responses we have received so far. Peter and Mike, Peter, do you want to add anything?
Yeah, I can add. So for tech applications, we do ask what is the customer's panel capacity and if they required a panel upgrade. And this is for both HVAC and water heating, whether or not they can receive the incentive for the panel upgrade. So we, at this point, have little over 1,800 applications. This is spread throughout the state. So at the conclusion of the tech incentives, I do expect we will have a very robust set of data to help map out panel capacities throughout the state.
Yeah, and I just to add on to that, obviously electrical infrastructure limitations are a key barrier to electrification, whether that's electric transportation or heating or water heating. And so a question that we're pretty closely that we're trying to get to the bottom of here at EPRI, and we do this year have a project now going in to conduct a national survey. So I'm interested in finding out the answers there as well. I guess I'll say colloquially, we're hearing that as an issue bigger in California than we are because of the high proportion of natural gas as the heating and water heating fuel. I think it was Amruta's data that showed, what was it, more than half in California? Sorry, the national average is about half. In California, it was much more than half was gas.
We have a couple of questions about data availability. And Peter, are your data already alive, or when will they be available? And
yeah, we expect our first set of data to be available sometime this summer, probably July or so. Again, I mentioned at this point we've received about 1,800 applications, and so now it is taking in all that data, putting it onto a public-facing dashboard. So developing that public-facing dashboard, that development will take place over the next few months. So be on the lookout for about a July launch of that data.
good. And I hope there'll be some way of notifying people who've been at this conference or other ways to get to them. The last question I see is from Xudong Wang. And
excuse me, Harvey, I'm sorry. We're actually at time for this session, so we're going to have to migrate over to the Zoom. And of course, you can take that last question with us, just so we can have a bit of a longer Q&A session. So Harvey, why don't you take it away and direct people to the Zoom link so that they can join us in the discussion afterward.
Now, they are supposed to see on their screen the link.
Yes, you should all be seeing the Zoom link and password on your screen by the chat box. So please head over to that link and join us in the Q&A via Zoom.
Would you repeat where you're supposed to be seeing it, please?
Yes, they should be seeing the link by the chat box. Us presenters have it separately via email, but the audience will be able to see the link by their Q&A box, and they should follow us all over to Zoom. Thank you guys so much. Thank you to our wonderful presenters. And I'm going to end this session shortly, and we can pick up on Zoom. Thank you so much, everybody.